Okay, so let's say this was your projectile motion question. We've got an initial velocity of 840 meters per second at an angle of 60 degrees with the horizontal. The question wants you to find the maximum height of the projection and the horizontal range. Now, the very first thing I'm going to do on any projectile motion question is write down, whether it's going to help me or not, just write down the 4 things we can assume. And this will get you somewhere, even if you're stuck with no idea what to do. So my 4 things that I can assume are that x dot is equal to v cos alpha, y dot is equal to v sine alpha, then x double dot is equal to 0, and y double dot is equal to negative g. And if you aren't aware of that, then watch the last video again. Okay, if you have no idea where to start, you do start at these. Straight away, I can see that I can sub in my value of v and my value of alpha. And simplified, this will give me that x dot is equal to 420 meters per second and y dot is equal to 420 timesing by root 3 meters per second. So they're my initial velocities in the horizontal and vertical direction. Okay? Alright, the first thing I need to find is my maximum height. Thinking about my maximum height, we know that if this projection leaving the ground comes around and it lands over here, my maximum height is going to be the y value at the point that the maximum occurs. And let's think back to our calculus. We can find a maximum by solving the first derivative equal to 0. So I say to myself, okay, I need to find the maximum height. So to find a maximum, I solve my first derivative equal to 0. And we're talking about a vertical height here, so that's why I'm solving y dot equal to 0. Think, okay, this is a good start. I need to find y dot. How do I find y dot? Look back on the video before. I said that you take the integral of y double dot with respect to time, which will be then the integral of negative g dt, which is going to give me negative gt, because g is just a constant, plus c. And there's my y dot. Now, what are my initial conditions? I know that at time is 0, y dot is equal to 420 times root 3. Sub them in, I get 420 root 3 equals negative g, which if they don't mention what to take g as, you take it as 10. Usually though, they will mention it. So therefore c is equal to 420 root 3. So therefore my y dot is represented as negative gt plus 420 root 3. Okay, now I've got an equation for y dot, and I'll just mention that I'm taking, because it hasn't mentioned it itself, g equals 10, which you can do. So more simplified now, I have negative 10t plus 420 root 3. And I think to myself, okay, what am I doing again? That's right, I'm solving my derivative equal to 0. So when is 0 equal to negative 10t plus 420 root 3? Rearranging that, you'll find that t is equal to 42 root 3. And it's seconds. So what that tells me is that my maximum height occurs after 42 root 3 seconds. That's not what they wanted. They wanted what is the maximum height. But at least now I know what time it occurs. I could find what it is if I knew what y is equal to, and I could just sub in t. So I think, okay, well, how can I find y? Go back to the video before, I can find y by taking the integral of y dot with respect to time, which is now going to be my integral of negative 10t plus 420 root 3 with respect to time, which is going to give me add 1 to the power and divide by it, add on your variable and your constant. Now, what do I know? I know that this particular question, it started at 0. In other words, it didn't have a projectile out of a building that was 10 meters tall, or it didn't have somebody throwing a shot put who was 2 meters tall. So I know that the height of this projectile was at 0, at time is 0. When I sub those values in, I'm going to get that c is equal to 0, so therefore, now I've found the equation of this particle with respect to time for the height. And I know that the greatest height was at 420 root 3, was it 4? No, sorry, my greatest height was at 42 root 3 seconds. This one here. So I'm going to put that in now where my t values are. When I do that, I'm going to say and when you sub all of that in, you get an answer of 26,460, and now we're in meters. So I know the maximum height of this projectile here was my 26,460 meters. Okay, part 1 done. Part 2 wanted the horizontal range. So part 2 wants to know what is the length of that line there. That's my range. Or in other words, if I just knew my x-intercepts, I would know the length of that line, okay? So I think, okay, how do I find that? I just find an x-intercept. How do I find an x-intercept? I make y equals 0. So let's make y equals 0. I know that y from my previous question is equal to this. Solve that equal to 0 and rearrange for t. The best way to do this, I have 2 values with t in both, so factorise out a t. I'm going to have, oh sorry, this is negative, so I'm going to factorise a negative t out just to make my life a bit easier. So I have here 2 answers. At time is 0 and time is 420 root 3 on 5. Which makes sense, right? Because there's 2 x-intercepts. There's an x-intercept at time is 0, and now we know there's an x-intercept at 420 root 3 on 5. But the thing is, they don't want the t value, they want the x value. So now that I have the time that occurs, I need to find an equation that's x equals and all in terms of t's. I need an equation that does that. So I think to myself, okay, how do I find x equals? I remember from the video before that to find x equals, I take the integral of x dot with respect to time, which is going to give me, I know that x dot, I already worked that out, here is 420. So I can make that substitution straight away. I'm finding the integral of 420 with respect to time, which is just going to be 420t plus c. Now, at time is 0, x is 0, because it's starting at the origin. It doesn't tell me otherwise. So c is going to be 0, so therefore the x is just going to be 420t plus 0, or just 420t. Now I just sub in my time. So I now know that the x value is going to be 420 lots of 420 root 3 on 5, which gives me approximately 61,106.75 meters. So this projectile lands 61,000 odd meters away from me. So that sums up that question there. I'd be also making sure I'm writing therefore statements to justify my reasoning, and the fact that they're going to be worded questions, so worded questions, worded answers.